This is a presentation from Exact Consulting about how to use Rational Developer for Z-Series in connection with a source control management system.
Today most installations have a source control management system set up to match their development process. The problem I want to discuss arises when you want to migrate from 3270-based development to Rational Developer on the workstation. In most cases the two products are from separate vendors. It is not trivial to make them work together and to match the way you want to work. I will first discuss SCM systems. Then talk about RDZ. And finally look at how to make them work together. Let us first look at source control management systems. In the old days we did not use source control management. We were what they now call agile. Big installations soon enough found the need for source management and configuration management. And most of the rest of us needed it badly up before year 2000, when we had to convert entire systems and still needed to fix bugs and add features at the same time. Replacing in-house personnel with contractors and dividing the work with offshore teams has made it even more important. This is an example of stages in a life cycle. The name of the rows varies between library management, source control management, application lifecycle management and other names. They mostly cover the same thing, but there is a difference in age and in functionality. When we talk about terminology, I can't resist talking about ITIL as well. In ITIL these systems are part of the service transition stage. The process called change management aims to ensure that standardized methods and procedures are used for efficient handling of all changes. The process called service asset and configuration management aims to maintain information about configuration items required delivering an IT service, including their relationships. And finally, the release and deployment management process is used for automated distribution of software and hardware. If you have ITIL, you definitely need an SCM. This chart gives a feeling about the history of SCM systems, and how they differ from each other. It talks about non-mainframe systems, but it still gives us a perspective. Then what does a typical SCM do? These are the types of operation you would expect. Traditionally an SCM has a 3270 ISPF-based user interface and a number of batch flows and started tasks to automate work. So you need to customize procedure libraries and ISPF panels to match your compilers, your runtimes, and your environments. Mainframe SCM systems go back to the 1970s, when source code moved from punched cards to disk drives. Do you know the story about the French company that had a problem with a program written for them by Oak Ridge National Labs in the US? The programs never worked when loaded in France, but the US systems house swore blind that they did at their end. Eventually, in exasperation, someone followed the working set of punched cards from the US to France. At French Customs, they observed a customs official remove a few cards at random from the deck. Apparently, the French Customs are entitled to remove a sample from any bulk item, such as grain, so a few cards from a large consignment shouldn't matter. Anyway, we moved on from homegrown systems through simple systems like Librarian and PanValid to the large, complicated and expensive systems of today. Endeavor is by far the market leader today, and the newest contenders are ISPW and Rational Team Concert, which are designed to span many platforms and to help dividing the work across countries and continents. Librarian provides library management and change management on the single-member level. PanValid is a library management system that centralizes the storage of application source, JCL, object modules and data. Both Librarian and PanValid are what you would call stabilized products. SCLM is a library manager and a configuration manager that can build and promote modules. It has been part of ISPF since around 1990. ClearCase was developed by Atria Software and first released in 1992 on Unix and later on Windows. It had roots in an earlier system from the 1980s. It is a modern system, now developed by IBM Rational, but I would expect it to be replaced by Rational Team Concert over the coming years. Endeavor is the flagship SCM product from CA. It is a source code management and release management tool. It is said to have a global market share of 80%. Serena ChangeMan ZMF is a change management product that automates and controls the process of migrating application software components from a development environment to a production environment. ISPW is both an application lifecycle tool and an integrated development environment. It has only very recently entered the Nordic market. And finally we have Rational Team Concert for System Z from IBM, which combines the features of a modern SCM with collaboration and team features. The term now is Collaborative Lifecycle Management. Now that we know about SCM systems, let us see how they go together with RDZ. Why do you need an integrated development environment in the first place? To put it shortly, because it makes life easier for you as a developer. Even easier than ISPF does. You have probably customized your SCM to suit your processes, or you have customized your processes to suit your SCM. Or even both. Now you need to do it all over again with RDZ. There are 3 components of RDZ. On your workstation you have the RDZ itself. Here you do all your daily work. On the host you have a component called Developer for System Z, which normally just sits there waiting for your commands. Between them you have a connectivity component, based on TCP/IP, which can use file transfer, remote execution, SOAP, REST and other protocols to connect the others. The host component works with all the compilers, assemblers, preprocessors, linkers, and binders that you are used to. It is the same tools you have been calling from ISPF and Batch. You will still get the same error codes from the same mistyping. You also have the same source control management systems and debugging tools that already helps you doing your job. And the transaction, database and messaging runtimes are the same too. You still use Kix, DB2, IMS and MQ as before. So RDZ and the other features in your workbench connect to perhaps a dozen applications on the host. These applications, tools and runtimes all have their own way of communicating with the outside world, to which your workstation has been adapted. To RDZ your SCM is just another application on the host. So how do you integrate RDZ to an SCM? Basically there are 4 ways to do it. You can use Karma, which is part of RDZ. Some vendors have supplied their own specific interfaces. There are third-party interfaces created by system integration companies. Or you can use the published API to RDZ and roll your own. Let us look at Karma first. Karma is a generic interface between your workbench and your SCM. On top of Karma runs a repository access manager or RAM. We will look closer at that on the next slide. Karma exists as views in RDZ and as a subtask in the Remote System Explorer daemon on the host. Requests from Karma views in your workbench are received by RSC and passed on to the RAM. A RAM is a piece of interface software that the SCM vendor or IBM can supply. Or you can write your own. Karma on the host supports this list of functions as calls to the SCM. It is up to the SCM which ones to implement. Some vendors are not satisfied with the Karma interface. They are using the RDZ Remote Resource Access API or perhaps an even deeper and dirtier method. This is the authorized way to connect to the host part of RDZ. In the Workbench, a Remote Resource Access API provides an abstraction to remote artifacts on the host, and the Project API provides an abstraction to projects in RDZ. The transport is provided by the Remote System Explorer framework. A number of small systems integration houses have built their own generic interfaces between RDZ and SCMs. I have seen cases where the SCM supplier insisted that the interface to RDZ worked fine, but the user company was not satisfied. In this case they looked at a third-party interface that in principle could be customized to fill their purpose precisely and exactly. The fourth and last possibility is to roll your own. If you want to roll your own, you have these three options to choose from. It would probably be very entertaining to find the proper documentation and to code them. It could be even more challenging to test them and to be stuck with the maintenance over the coming decades. As always in an IT project, the real challenges are not technical. They have to do with people and the way that they work. We need to get new people into mainframe development. So we need to give them tools they can feel comfortable with. And the experienced developers need to use the same tools to meet them on common ground. European developers have the advantage of knowing our businesses, their culture and their organization. But we also need the new tools to get more productive. Our new young colleagues in India and China are already embracing them. Much of the old code has lost its clarity and structure over the years. We need tools to analyze them to be able to keep on maintaining them. This calls for the combination of SCM and development tools like RDZ. Let us first take a look at SCLM as an example. We will see how it is installed and configured, and then we will see how it can be integrated to RDZ. As the name of the product indicates, SCLM has two main functions, the library manager and the configuration manager. Together they give you a fully functional SCM system, which is free, but which is inferior to the market-leading products, and which is way too complicated to configure for a project administrator. You install the SCLM product while installing ISPF and the rest of your ZOS system. It resides inside the ISPF system libraries. The SCLM project is implemented as a logical database, consisting of source, load modules, procedures and vsam files. SCLM is option 10 in ISPF. Option 7 in SCLM will create a sample project. These are the data sets that have been created and populated. Note the structure, where the high-level qualifier is the project name, the middle qualifier is the promotion group, and the low-level qualifier is the artifact type. The PRODIFS data sets in the middle are the metadata for the project itself. Let us look inside PRODIFS source. This member is the actual definition of the SCLM project. It consists of assembler macros with a wide variety of parameters. You can see that we have two groups at the first stage, called DEV1 and DEV2. The promotion path then goes to test and finally to release. The project administrator is supposed to design the project this way. No drag and drop. Just macros. That could be one reason that SCLM never has become overly popular. This is a graphical view of the sample project. When the project has been configured, and the build procedures have been customized as macros and as regex execs, the developer has a reasonable environment to work in. When you select one of the commands, then compile, bind or promote will be executed for you. Now that we have SCLM running, we add RDZ to the pot. We have two interfaces from RDZ to SCLM supplied by IBM. There is a Karma interface, which requires that you code your own RAM. Don't let it confuse you. Just ignore it. The real RDZ implementation is called SCLM Developer Toolkit. It is an Eclipse-based plug-in application that provides SCLM services to Eclipse projects and host-based SCLM projects. It supports both workstation and mainframe-based languages. And I have almost grown to like it, when we used it on an internal project, where two of us developed a COBOL dynamic link library with shared functions for a conversion project. There is not much configuration work here to do for the systems programmer. You have to update these configuration files in the Unix file system. If you want to manage workstation files like Java programs, You must configure translation support between long and short names and probably also the add tool. Finally, you need to update SELM to define the parts specific to SELMDT. Now let us have a look at SELMDT in action. You might have noticed that we did not have the COBOL editor activated with syntax check, quick fixes, content assist or any of all the other useful features. This is because SELM wants the dataset type to be called source, while RDZ expects it to be COBOL. This can be customized in RDZ, but it is a good example of the conflicts between the products. As you can see from this slide, however, is that the syntax check is working the same way as in plain RDZ. As mentioned, Endeavor is the market leader among mainframe SEM systems. Some years ago CA built its own Eclipse plug-in to support environments like RDZ. It had a lot of features, but did not fit seamlessly enough into RDZ. So now the RDZ people have built a Karma implementation for Endeavor, and they have it high on their priority list with improvements in every release of RDZ. When you have Endeavor running, and you have installed and configured Host Developer for Z, then the interface configuration is rather simple. Most of the components are ready as they are out of the box. You have to decide whether to run the interface in batch or as a subtask in the Remote Systems Explorer. Then you have to create and populate 3 vSAM datasets. The last part is the edit some configuration files and some procedures and jobs in partitioned datasets and in Unix files. A few scripts have to be submitted, and then it should all be working when you have recycled the RSC daemon task. We live in conflict between two environments. They do not fit seamlessly together, but you have to move artifacts between them. This is not fully intuitive when you have them all visible in the same workbench. Let us have a look at the action as seen from the user side. Serena ChangeMan ZMF is another popular SCM, used by many installations in the Nordic area. The integration is done by Serena's own Eclipse plug-in, which communicates to the software repository outside of RDZ. The ChangeMan solution consists of 3 components. The Workbench plug-in is an Eclipse plug-in that can be installed into RDZ. The plug-in invokes a web service on a web application server. The web application server can reside anywhere in the network, but must support the Apache Access SOAP library. The web application server and the web services use TCP/IP to connect to the ChangeMan software repository on the mainframe. This is the perspective provided by Serena when installing the plugin. And here we have the Serena Explorer providing a view directly into the repository. To check a component into a ZMF change package from an RDZ project and submit it for build, you right-click it, then select ZMF RDZ and then select Check-in. Rational Team Concert is a sister product to RDZ and very closely integrated with it. It is very strong on project management and team collaboration, but most installations have so far kept their existing SCMs rather than converting to the source control management part of Rational Team Concert. Rational Team Concert is a package with many usage patterns. You can use the build functions in RTC to build and promote your applications, and the source control functions to manage your RDZ workspaces and repositories. Or you can use RTC for project management and team collaboration, and then let your existing SCM do what it does. This is how RTC looks when accessed from inside RDZ. You can see how team collaboration, work items, builds and changes are connected and visible inside the same tool. Integration between RTC and mainframe source control takes quite an effort no matter which product you choose. Here is an example of how to integrate RTC with SELM using RexX and REST. So what have we seen? We have seen where the SCM and RDZ are in conflict and some ways to mitigate it. We have also seen a variety of technical solutions to the integration issue. And we have had a glimpse of what it looks like to the developer.
This has been a presentation from Exact Consulting about how to use Rational Developer for Z-Series in connection with a source control management system.